Okay, hello, how are you doing today? I am doing fine myself, and I am going to take you through a little example, if I can see. It's too small. For example, 3, and at this point, you should be seeing a little picture of me and a big picture of Dr. Taylor's example. I chose as my example topic the effects of teacher SES. And this chart or table that you see below is something that you have in the resources tab without the red writing. And it is something that I've also posted above this video in lesson 3. So I'm going to go through a few of these today for lesson 3, or excuse me, assignment 3, discussion post 3. And we're going to look at how my topic can play out differently given different kinds of analysis. So here's how you read this chart. Looking in the first column or row here, what's the chi-square test do? Well, it compares one independent variable and one dependent variable, and it answers the question, do differences exist between groups? Okay, well, in my example, if you're talking about groups in teacher SES, then you're going to be talking about a high SES, a middle SES, and a low SES. Okay, yes, teachers can have a low socioeconomic status. If you're making the absolute minimum for what a teacher can make in some school districts. And that's your only income for the family, you may be in a low SES category. So my independent variable is the categories of SES. That's one category that has 3 things within. That's one idea, one factor, one variable that has 3 categories. Okay, so that's one independent variable of SES. And then what I'm gonna look at is, well, I have the effects of SES. Well, in terms of teacher retention, I'll try to zoom in on this question a little bit more. I asked the question, do differences in retention, with the dependent variable being, do they stay or do they leave? That's a categorical variable, which the dependent variable has to be. Okay. So it's categorical, do they stay or do they leave? Do differences in retention exist between teachers of different SES groups? Okay, so there's one DV, one IV, each has categories within that variable, but it's one independent variable and one dependent variable. And I ask this question, do differences exist between groups? I did it with my groups. Do the differences in retention exist between teachers of different SES groups? So I'm taking their question and I'm putting my information in it. It did not change the question. I just put the specifics in there. The question that you ask determines which form of analysis you can use. So let's look at the next question. And in this case, this is specifically it's very different, because here we've got categories, but it can only be dichotomous, which for a t-test, your categories have to be dichotomous, which means you can only have 2 categories for your independent variable. So for me, my independent variable is going to be the SES, and I'm going to only use high and middle. And the reason I'm using high and middle is because most teachers aren't in low. So I'm just going to take that out of the equation, and then I can run a t-test on these, comparing these 2 groups and saying, is there a difference between these 2 groups on my one dependent variable, which in this case is the mean level of teacher effect. Okay, mean level of teacher effect. In Tennessee, we have teacher effect scores. They're very private, and so is the teacher's SES. But if I could collect that data through various means, and I could look at it, then I could compare, do higher SES teachers have higher teacher effect data? Are they lower? Are they the same? Does it make a difference what SES the teacher is in? We already know that the student is, but this is what I'm asking. And the important thing here is, for t-test, I'm asking, do differences exist between 2 groups? Okay, that's the high SES or middle SES on one dependent variable, which is teacher effect. Okay, so you have to look at your question and see what it matches. You've got to see what type of variable you have. If you've got scores on tests, it's usually continuous. If you're looking at categories, you've got to look at, is it 2 categories? If it's 2 categories, that's dichotomous. But any number of a category that has 2 or more is fine for these ones that say categorical. You've got to go through and understand what you asked. So let's take a look at the next one down. Okay, we just looked at the t-test. What's an ANOVA? ANOVA is a slightly more complicated version of a t-test. And as you can see here, it does 1 or more categorical variables. They don't have to be dichotomous. You can have 3 categories, or 1 variable with 3 categories, high, middle, and low. But you can have more than 1 independent variable. You can have 2, you can have 3, you can have 10. Probably not for your dissertation, though. Let's keep it simple. Okay, continuous is the dependent variable. So here I'm going back to scores. And my question about how teacher SES affects things are the mean score of teacher effect, so same dependent variable. Are they different depending on the level of teacher SES? So what's the big difference between this and the last one? Well, the last one I could only have 2 categories because t-test is for dichotomous, only 2 groups. So on the t-test, I could have high and middle. But here I can do high, middle, and low because there's no limit. It doesn't have to be a dichotomous category. It can have more than 2 categories within it. So there you go. That's a very minor difference, but it changes what test that you can run and get the actual answer. So you've got an ANOVA. The ANCOVA is the next one on the list, but I'm skipping that. I'm going to save that for lesson 4, as I am with the MANOVA and MANCOVA, because they are much more complex and you need practice with the simple ones first. The correlation, and this is most of the medical studies that you hear are correlational. If smoking goes up, does the rate of cancer go up? So how strongly are these 2 variables related? So instead of see, in this correlation, I could have done dichotomous, which would be just high and middle income. But what I chose to do is go with a continuous variable related to SES, which is the teacher's family gross income. So I said, is the teacher's family gross income related to the teacher effect scores? What's that mean? As the money goes up in the teacher's family, do they have a larger effect on the student growth? So as one thing goes up, does the other one go up as well? It could have a negative effect. They could be so rich that they don't care as much. I know that's probably not right, but we don't say, they put directionality in there, and I say rarely put directionality in there. You let the test tell you whether it's a positive relationship or a negative relationship. I say leave it open in the question. So are these things related? And that's a very weak thing, relationship to make. It usually oversimplifies things if you only have one variable, one independent and one dependent, and you're saying, do these go together? So usually I will ask you to do more pieces of your study to inform it and make sure that that's really the thing. But we'll talk more about that and confounding variables, like what kind of school is it? Is it elementary, middle, high? Is it low SES students? Is it, there's so many other things that go in there. So correlational studies are interesting, but you need to do several more things to really get a full picture. So we'll talk about adding complexity in lesson 4. But for now, does this dichotomous or continuous variable relate to this? We're not saying it causes anything. We're just saying whether it's true, whether they're related or not. One has an effect on the other, possibly in one direction or the other. Okay, that was my first example, and I just chose effects of teacher SES because nobody does that. I didn't want to do your tests for you. But now let me go through and give you, I'll just tell you some examples of some of these things that are that students perhaps have done at Carson Newman. Do differences exist between groups? Okay, and this is categorical independent and categorical dependent. So one example is, do athletes, do high school athletes, which is defined by participating in one or more sports, have different achievement level than non-athletes? So my independent is athlete. It's one category, it's athlete or not. And my dependent variable is high achiever, low achiever. Actually, it could be high, middle, low, because categorical means you can have any number of categories within that one variable. So that's something that you could do with the chi-square, athlete or not, and is there a difference between the athletes and non-athletes in terms of achievement, high, middle, or low? That's a chi-square kind of thing. On a t-test, do differences exist between two groups on one dependent variable? Now, very commonly, you want to do a classroom intervention, and you want to know, you may have an experimental group and a control group, where the experimental is trying something new and the control group is doing what they've always done. And those are two groups, the experimental group and control group. That's a dichotomous variable. Are they in this group or that group? So that's the independent variable. And then the continuous variable in that experiment is going to be the growth. So you'll do usually a pre-test and a post-test, and subtract, see what the growth is. And that growth is your continuous variable. Is the mean growth of the experimental group actually bigger than the mean growth in scores of the control group? So that is very, very, very common practical thing for teachers who are trying to try out a strategy, and it's a dissertation, so you have several classes doing this and several classes not doing it. And that would be, the question would look like, do differences exist in the mean difference between pre and post when comparing the experimental and the controlled group? The group that uses reader circle and the group that doesn't use reader circle. The group that uses an integrated math approach versus the group that uses a traditional math approach. ANOVA is highly related to t-test, so it's very similar, and now you can just do more than one independent variable. So you could have both experimental and control group being one of your independent variables. That's one group of two categories, you're experimenting or not, and another categorical variable that you can use on the front end as an independent variable is male and female. And then you can look at the growth, how much did they improve from pre to post test. So in this case, that'd be another example, a very common example of using two independent variables, experimental or not, and male and female, and one dependent variable of score improvement. So that's another very, very common approach and a very common test to use. We're going to leave those other ones again, but correlation, you saw my correlation. It's kind of, is there a strong relationship between I would just stutter on this one. Is there a relationship between the IQ score on record and the present achievement level in math class? Is there in high school a relationship between the grade level of the student in Algebra 2 and the achievement level, their current score or grade overall? Okay, that's a correlation. Do seniors do better in Algebra 2? Do they do worse? Is there a relationship at all? Maybe it doesn't have anything to do with anything. All right, I'm sure I've confused you a little bit, but I'm doing my best here. And I'm taking you through a few examples. And of course, the book explains all this too. And I'm just trying to add a little bit of depth and tell you what I think. And here's the thing, when we go to chapter 3 and you start writing chapter 3 and you tell me what, you already tell me the exact research questions and you tell me the exact methods that you want to use, I'm going to go to this this table, this chart, and I'm going to look at it and see if the question you've written matches your analysis. Because we don't get choices. This is very, very, very specific statistical method, and you can't wish it into being a correlation. If you say, is there a significant difference? Well, difference is not in the correlation question. If you don't say the word difference between groups and you say, what's the relationship between this and that, then that is a correlation and you can't make it a C-test. It's gotta, what you ask has to match the method. So that's why we're practicing writing questions to find out what kind of question you might want to ask and what kind of answer that you know you can get out of it. So that's why we're doing this assignment, and we'll add complexity on assignment 4. But for now, we will just cut it off, and I will make a different video where I fill in the rest of the blanks on that table. All right, sorry about the little brain farts in there. I guess I need to eat lunch. We're all human. Let me know when you have questions, and do remember, I'm going to say it over and over, don't be a perfectionist. Put up your answers, put up your questions, and say, this is a t-test, and here's why it's a t-test. Here's my correlation, and here's why it's a correlation. And if you're mistaken, that's why we're doing it now, so we can get things corrected, get everything sorted out. You're giving each other comments and trying to work out the details in your brain so that you know what you can ask about your topic. And that's the thing, this is your topic. You shouldn't mess with other topics. This is you in the sandbox playing with what you're going to do for your dissertation, finding out which things can do what so that you know which one you might want to do. All right, so take it seriously, but know that we're going to correct each other along the way. So just get it up there, give it a try, and make sure you give feedback to others. Not just because I give you points for that, but because we want to seriously help each other out. We're all trying to graduate and get this dissertation done in a year, and this is an early part of the process. So be the helper, and I will see you online.